Okay, so 4-8 is where we are. So what's up with these? This is a thing that our book calls literal equations. I've seen other books call these other things. What's different about these when we look around our board? There's two variables or more. So what they're going to do to communicate to you which variable they want you to solve for is they're going to underline one of the letters. And that's the one we want to try to get alone. I don't have a real great interest in underlining these all on the board, so let's just act like I underlined all the x's. So all of these problems behind me, we're going to always solve for x, except the very last one I underlined the y because it was in a different position. But I'm just going to solve for x every time. But in your homework page, don't underline the letter you want to do. There's no real difference to this process-wise of what you've been doing. You're solving an equation, so you're always going to do the opposite. Whatever you do to one side, you'll do to the other. You don't have much of a way to check. My opinion, in some ways, these are easier because sometimes when you go to solve and you're doing the opposites, you like multiply wrong, or you divide wrong, or you forget to reduce, or you miss a sign, or the positive negative rules bite you, or something. There's no real chance to make those kind of mistakes. Then look harder because there's more letters, but if you can get yourself over the hump of, okay, there's more letters, I'll just deal with it, in a way I think these are easier to do. But we'll see what you think. So this, I look at the board, I see some adding, so your job is going to be to do some subtracting. You're going to want to subtract which letter? Y. So when you go to get this x alone, the 7 didn't need to change. We said we were going to subtract the y. And you write down that for an answer, and I'm a happy man. If you want to show a little work, if that makes you feel a little bit settled, we could go ahead and show on each side we're subtracting the y and draw the line and do the cross outs like we used to, but you're still going to get 7 minus 1. Here, you look at the board, you don't see adding this time, you see multiply. So your job's going to be to divide. Divide by which letter? Y. So when you get the x alone, if we're dividing by y, the 7 minds its own business. We divide by y. That's my answer. I'll move on. Something about that move. Okay, this time we see dividing, so you're gonna multiply. So if you get the x to be all alone, that's going to look like 7 multiplying y. Last one of that stack, you see subtracting, so you're gonna add. If you get the x alone, that's going to be 7 plus y. So there's 4 different moves, little one-step problems there. They'll get a little bigger as we go. Some of these will take more than one step, but for now, start off with some one-steppers. Just do the opposite. Question about what happened there so far? Okay, for this, it's going to take us 2 moves. So for us to get the x completely alone, we've got to deal with the 4. We've got to deal with the y. What do we deal with first? Multiply, divide, or add, subtract?
Multiply, divide.
When we're doing like order of operations regular math, yes, multiply, divide. But when we're solving, we're doing the opposite, not just in the operations, but in their order as well. So first, we're going to want to add or subtract. So 4x would wait its turn for a minute. How would you get the y out of there first? What would you do to get the y gone? Subtract. And this side would become new. 7 minus y. To get the x completely alone, what are you going to have to do with the 4? 4's now got to go. Divide. So this whole thing would want to divide by 4. I think the easiest way to write that is a fraction bar that puts it all on the top and then does the 4 on the bottom of everybody. It's not the only way you can write that, but that's probably what I would do. Something about that. Alternate plan. You could do 2 different fractions. You could do a 7/4 fraction, subtract, and have a y over 4 fraction. These two things mean the same thing. That's kind of up to you what you want to do. So if we want to solve this for the x, well, we'll have to get out of there first. The 4y. To get rid of adding 4y, you're gonna subtract 4y. So 2x can wait its turn. If you subtract 4y, 10 minus 4y. Then what would you do? Divide by 2. Unlike last time where I said I didn't care if you divided because 4 couldn't divide, this time I want you to divide because you can. I can divide 2 into these things. So let's just do that. 5 minus 2y. Something about that. This, you have 2 plans. Anybody have a suggested plan? Distribute. Most people would say distribute. Did anybody have a different plan? Okay, let's just follow through on that because that's probably what you would have done. But I'll take you on a plan B in a second. Distribute would get you 2x plus 2y equals 6. If our goal is to get the x alone, who's got to go first? The 2y. How would you get rid of the 2y? Subtract. And that would look like 6 minus 2y. Agreed. To get the x completely alone? Divide. Can we? Yeah, so let's do it. Agreed. Question about that? Okay, there is a shorter path than that. Rather than distribute, we had a trick on trick day.
Is it that 2 goes into 6 3 times?
2 can divide into 6 3 times. So we could wipe out the 2 by dividing into 6 3 times. We'd still then get to the same answer just with less work. You don't have to do that, but it's a good trick. How about that? For this one, fractions, oh no, make people mad sometimes. How would you get that fraction out of there? Multiply by it?
Or divide.
Divide by it? How would we do that? When you divide by a fraction, how do you do that?
3 over 2.
We're going to have to flip. Okay, so this is trying to multiply. This fraction is trying to multiply. So that means we have to divide this fraction. But when you divide a fraction, it flips. So when we go to attack this other side, y minds its own business, but it's joined up with 3 over 2. And again, if you want to show some work, that's fine. What we really are doing here is multiplying by 3 over 2 to get some nice cancels. This is multiplying by 3 over 2 to just create a new thing. This one, 2/3, still the same fraction, 2/3 still has to go, so that means 2/3 still has to flip. So there's a 3 over 2 attacking this side. 5 is like it's over 1. Join that stuff all up.
15 over 2.
15 over 2. And then the y could go one of 2 correct places. You could either put that with the 15 on the top, or just not on the bottom, just right beside it. So I could either extend this and do the y upstairs, or I could put the y when the fraction ends. I just can't put it on the bottom. Just put that wherever you want. One more of those, same kind of thing. Again, we get the x alone, the 2/3. We're going to again have to flip. 3 over 2 is going to go interact with the other side.
15 over 14.
15 over 14. And again, for the second thing in a row, to put the y, it could either go up top or just right beside it. Question about those 3 stacks? We'll get a brief timeout to adjust our view. No real difference over here for the last couple stacks, other than the problem's got a touch bigger. For this one, we've got two things to do. If we want to get the x alone, how are we getting the 2/3 out of there? Dividing by it, which makes it 3/2. We'll have to flip it. How are we going to get rid of the y? Divide by it. Which of those seems like more work? So let's leave that. Okay, so 2/3 I'll leave for a second. X is what we want alone. Let's attack the y first, just because it's easier. It's not right or wrong to do it in this order, but I think it's just easier to get after the y. What would this side look like if we just get after the y? Z over y. Then it's a little clearer, I think, to figure out what's going to happen with this 2/3. When the 2/3 goes, we said again we're going to have to flip. So 3/2. Put that all together, and the top would have a 3 and a z. Bottom has a y and a 2. It's normal to put the 2 before the letter. Let numbers then letters is just the way that usually looks. About that one. Let me skip to this one and go back to the middle, because this one seems easier to me than this one does. I've got a 7, x, y, z. I'm trying to get the x alone. What's all of that going to have to do? What are we going to have to do to get rid of any of these other pieces? We're going to have to divide. Does it really matter what order we go in? No. So take what piece is easier. Which of these three things seems like it'd be the easiest to divide by? I'd say 7. If we divide by the 7, x, y, z, weight, and that makes this 3. To get these out, is one easier than the other? Not really. I'll do them one at a time, or you'll just take them both on at once? I'll just take them both on at once as well. If we get the x alone, y and z both have to divide. So what's that going to look like? 3 on top of yz. Something like that. Why is this one the worst so far?
It's the biggest.
It's the biggest. What else is the worst about it? There's a variable on each side. There's a 6x over here. There's a 10x over there. So the first thing we have to do is get rid of one or the other of those. How would we get rid of this one? Subtract 6. How would you get rid of that one? Subtract 10. They're both correct. Which one's a little easier to do the math? Subtract 6. Why is subtracting 6 easier? Stay positive. So 2y can wait. Negative 16y can wait. In our mind, we're subtracting 6 here, so we're subtracting 6 there. That is 4x. And again, if it makes you feel better, show the minus 6x stuff. Like draw the line the way we used to do that when we started to do these opposites. Those are gone, those are changed. That's totally fine. Attacking this now, we want the x alone. Who's our next attack? 16y. How do you get rid of subtracting 16y? Add 16y. So if we're adding 16y, that is 18y. Question about any of that? How would you get the x alone then? Divide by 4. What would that look like for a minute? 18y on top of 4. Why did I say for a minute? Because we can reduce that. Our best answer would have a y in there, either on top or beside. 18 over 4? 9 over 2 would be best. About that. Last one of the day. This is a physics problem, so you're not worried about that one. What would you do about this? I would say distribute. Last time we took a shortcut, why would that shortcut not really be that great this time? Because we can't divide 4 and 1. But if this were like, what could I put here and then I would want to do the shortcut? Like an 8, anything 4 can go into. But we don't have that, so x would equal 12y minus 8z. Y is what we're hunting this time, not x. Every other one, you missed the beginning. The book will underline the letter we want to get alone. I just didn't feel like going through and underlining all my x's. So I told them before you showed up, just act like I underlined all the x's because I just didn't feel like doing it. I did it for the first 4 and then I was like, nah, I don't want to do that every time. So if we want to get this alone, who's got to go? How are we going to get rid of that? Add, so 12y is waiting, x plus 8z. Those are unlike, we just can't do anything with that. Get the y completely alone. No, not a subtract. Divide. What's it going to look like if we divide 12? All on top of 12. And that time we didn't divide because you really can't. I'd be happy with that. I'll give you one more I'd be happy with. Question about that. Plan B, you could do the x on top of 12 as one little fraction, plus the 8z on top of 12 as its other little fraction, and I'd be moderately happy about that. Why would I be a little bit grouchy about that one? Reduce one or both? Which one? The second one. This x over 12 is okay. This we could not tinker with the z, but 8/12 could go down to 2/3. I'd be happy with that. I'd be happy with that. It's probably easier to leave it like this. If you can't reduce everybody, just leave it. But if you do separate them into 2 different fractions and you can reduce one, that's okay, but I don't, my personal style, I'd rather not. You do what you want to do then. Something about any of this. 30 or so, not quite 30, what do we have? 25 minutes-ish left. We're working on 166 is our page. We're going 1 to 24. The last 6, after you do what they did, they'll say, oh, by the way, here's some numbers to stick in here. So if, let's say this is what we did, they say, oh, by the way, y is 6. They still want you to do all the math like we did it, but when you're done, put the 6 in there. So you could either do 15 times 6 and then divide 2, or you could do 6 divide 2 and then times 15. Which of those seems easier? To go 15 times 6, then divide, or do 6 divide 2 and then multiply? I'd say 6 divide 2, because dividing makes everything get smaller. So 6 dividing 2 is 3. 3 times the 15 is 45. But the last 6 do that. Every problem you want to do what we did on the board, but the last 6, after you did what we did, then they're going to give you an, oh, by the way, here's a number, stick it in and do a little bit of math on this. 166, 1 to 24, and that's a wrap.